हेलो दोस्तों, आज हम पढ़ेंगे व्हाट इज हर्विच पॉलिनोमियल. लेटर्स. First of all, let us assume an polynomial in the generalized form p of s is equal to a n s to the power n plus a n minus 1 s to the power n minus 1 plus a n minus 2 s to the power n minus 2 plus dot 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 plus a naught. Then comes the necessary condition. First point, p of s is real when s is real. Means the polynomial p of s is real when s is real. The function s is real. Then second point, the roots of p of s have real parts which are 0 or negative. Means the p of s, roots of p of s, polynomial has having roots. We know that polynomial are having roots. So the roots of p of s must be real, means 0 or negative. Then the properties of Hurwitz polynomial. All the coefficients of polynomial are positive. Means see, here the polynomial p of s is equal to a n s, means all the coefficients of the polynomial should be positive. Then second point, a polynomial may not have any missing terms between the highest and the lowest order unless all even or all odd terms are missing. This point states that, let us take an example, s to the power 4 plus s to the power 3 plus s to the power 1 plus s to the power 1 plus 1. Means here the in even part the highest degree is 4, here s to the power 0, so in even the lowest degree is 0. Between the highest degree of even and between the lowest degree of 0, there is no missing term, because we know 0 is even, then 1 is odd, then 2 is even, then 3 is odd, then 4 is even. So 0 is even, 2 is even, then 4 is even. So there is no missing terms in the polynomial. See, because after 4, then 2, then 0. If we talk about the odd terms, see, the highest degree of odd term is 3. So 3, then 1. So 3, then 1. So there is no missing terms of odd terms. So this is a Hurwitz polynomial and all the coefficients are positive. Then second point, here the highest degree is 4, then lowest degree is 0. Between 4 and 0, 2. Here 2 is missing, so it is not a Hurwitz polynomial. Third, s to the power 3 plus s. All the even terms are missing, so all the odd terms are present. Then also it is a Hurwitz polynomial. See, because here it is saying the polynomial may not have any missing terms between the highest and the lowest order unless all even or all odd terms are missing. Means it says that only one should not be missing. Either the whole even term or whole odd term should be missing, so that it can be a Hurwitz polynomial. Third point, the roots of odd and even parts of the polynomial p of s lie on the j omega axis only. Means the roots of the odd and even parts of the polynomial. Means we have to divide the polynomial into odd part and even part, and then we have to take out the roots of the even part and odd part, and we have to see that the roots of the even part and odd part should lie on the j omega axis only. If the polynomial p of s is either even, odd or odd, the roots of the polynomial p of s lie on the j omega axis only. Means this point and this point both are same. Fifth point, all the quotients are positive in the continued fraction expansion of the ratio of odd to even parts or even to odd parts of the polynomial. Means a polynomial p of s is given, we have to separate the polynomial into even part and odd part, and we have to divide the polynomial even by odd or odd by even. If the degree of the even is greater, we will divide even by odd. If the degree of odd is greater, we will divide odd by even. So sixth point, if the polynomial p of s is expressed as p of s equal to w of s, p1 of s, then p of s is Hurwitz if w of s and p1 of s are Hurwitz. Means when in question in this form is given, we will say p of s is Hurwitz when w of s individually is Hurwitz and p1 of s individually is Hurwitz. Then we can say p of s is Hurwitz. Then seventh point, if the ratio of polynomial p of s and its derivative p dash s gives a continued fraction expansion with all positive coefficients, then the polynomial p of s is Hurwitz. Then we will go to an example to understand all these properties. Let us see an example. Here, test whether the polynomial p of s is equal to s to the power 4 plus s to the power cube plus 5s square plus 3s plus 4 is Hurwitz. First of all, let us see the solution. Here the polynomial of p of s is given. Okay. Step 1. Given p of s equal to h to the power 4 plus h to the power 3 plus 5s square plus 3s plus 4. Then step 2. Then we have to separate the polynomial p of s into even and odd parts. Even part is expressed in terms of e of s. So h to the power 4. Here even parts are what? H to the power 4, 5s square, and 4 means 4 into s to the power 0. So we are only writing 4. So even part equal to s to the power 4 plus 5s square plus 4. Odd part is expressed O of s equal to s to the power cube plus 3s. Then step 3. As we know the degree of even is highest than the degree of odd, we will do even of s by odd of s. So s to the power 4 plus 5s square plus 4 divided by s to the power cube plus 3s. Then step 4. We will do continued division method. For denominator term, then the numerator term multiply we will do. After doing we will get 0, and we see that all the coefficients, but all the quotients are positive. As we know the property number 5 says that all the quotients are positive in the continued fraction expansion of the ratio of the odd to even part or even to odd part of the polynomial. So we get all the coefficients as positive by even by odd part. So as all the quotients are positive, it is a Hurwitz polynomial. थैंक यू दोस्तों. अगर आपको अच्छा लगा वीडियो तो प्लीज़ सब्सक्राइब करें और लाइक करें और कमेंट भी करें.